The law of sines. First of all, we're going to have three types of triangles. The first type will have two known angles and the included side. This would be angle, side, angle. The second type will know two consecutive angles and a side. That will be known as, if I read it this way, it would be side, angle, angle. And then finally, two consecutive sides and an angle. Consecutive. So we have side, side, angle. When we have these three types of problems, we use the law of sines. So the law of sines is a ratio. We have the sine of alpha over A equals the sine of beta over B equals the sine of gamma over C. And remember, B is across from beta, A is across from alpha, and C is across from gamma. Now we're not using right triangles here. These are not right triangles. So since they're not right triangles, we have to use law of sines when we have one of these three types of triangles. So let's take a look at an example. Okay, so looking at this example, notice that we're given a side, an angle, and an angle. So we have S, A, A. And so that's going to match this type of triangle. So that means we can use law of sines to solve it. So we're going to do the sine of, well, if this is B, that's beta. That's gamma. So that means that's alpha. So we're going to have the sine of alpha over A. Okay, and let's say we want to find B. So we'd have the sine of beta over B. Okay, solving this, we cross multiply. Okay, make sure that you are in degrees. Okay, so remember, go to mode, make sure you're in degrees. Remember, if you don't have a calculator at home, you can use desmos.com. That will also work for you. And so back to this problem. Clear it. So we're going to do 4 times the sine of 60, enter, divided by the sine of 40, enter. And we get 5.39, rounding to 2 decimal places. So B, side B, is going to be approximately 5.39. Okay, I'm going to go ahead and find gamma next. 60 plus 40 is 100. That leaves us with 80 left over. So remember the triangle sum theorem, they add up to 180. So it's going to be 80 degrees. Now we need to find C. So setting up another proportion, this time I'm going to go ahead and use gamma because I'm looking for C. So the sine of gamma, which is 80, I'm using this proportion here, or this ratio here, excuse me, over C, and I can use either one of these. So let's go ahead and use the sine of beta. Beta is 60 over 5.39. Oops, that's an approximate value. Alex, if you're watching this video, you know that if I can help it, I'm not going to use that. So I'm going to go ahead and use the other one. So I'm going to go ahead and use 40 and 4. So the sine of 40 over 4. Okay, so we're going to solve this. So cross multiply. Feel free to forward this. If you know how to do this, feel free to forward it, and don't waste the time watching it if you already know how to do this. And then dividing both sides by sine of 40. No, you cannot divide 80 divided by 40. So we're going to have 4 times the sine of 40, 80, divided by the sine of 40. And we get 6.13. And there are your answers. Let's look at another example. Okay, example 2. Notice we have an angle, an included side given, and another angle given. So we have angle, side, angle. Since it's angle, side, angle, if you look back up here at your triangles, we can use law of sines to solve it. All right, so setting this up. So let's start off with finding, let's find gamma. So we know that it adds up to 180. So 35 and 15 is 50. 50 from 180 is 130. So we know that gamma is 130 degrees. So now that I know an angle and a side, opposite side, I can set up the proportion. So we're going to have the sine of 130 over 5, these two. And if I want to find b, then I'm going to use these two, 15 and b, equals the sine of 15 over b. Okay, using the same procedure, we cross multiply, solve for b, we get approximately 1.69. Setting up the next one, I did the 130 and the 5 for the first ratio, and then I did 35 and 15 for the, 35 and a, angle to side, for the second ratio, and solve for a, 3.74. All right, next example. Okay, so here we're given two sides and an angle. Now, it would be very helpful to draw a picture, so I went ahead and drew a picture over here. Now notice across from alpha, 40, I put the a value. And then across from beta, I put the b value. Now notice this side should be a little bit smaller than this side. And then gamma would go here. So let's go ahead and solve this. Since we have an angle, this would be side, side, angle, side, side, angle. That matches one of the triangles. So we can set this up. Sine of 40 over 3 equals, we'll use these two, we'll solve for b, or beta, sine of beta over 2. Okay, so solving this, we're going to get 2 times the sine of 40 equals 3 times the sine of beta. So obviously we're solving for an angle here. So let's see what we get. 2 times the sine of 40, okay, divided by 3. So we get the sine of beta equals 0.4285. Okay, to solve for beta, we're going to do the inverse sign on both sides. Now on my calculator, what I'm going to do here is I'm just going to do, the more decimals I use, the better. So second sine, and then if I press second negative, gives me the answer. So it puts that last answer in the blank there. So I'm using all the decimals. So we get beta is 25.4 degrees. Okay, so beta is 25.4. So using the triangle sum theorem, gamma is going to be 180 minus 40 minus 25.4, and you get 114.6 degrees for gamma. So then to find C, we're going to use thanks Nick, got me saying that now. Sine of 114.6 over C equals, and then I'm going to go ahead and use these two, sine of 40 over 3. Solve for C, 4.24 approximately. Okay? Okay, so this next one, we're given two sides and an angle. So we have SSA again. This one's a little bit trickier though. I went ahead and put in my angle of 35. Here's my side. So then my angle, remember the A is going to be opposite of alpha. Okay, so I'm going to go ahead and put B in. This is going to be side, angle, side, angle. So here's the troubling part here with this one, is A is 6. Well, 6 could go just like this. That could be one possibility for 6, but 6 could also be this. So we have a possibility of two triangles here. Okay, so this could be the 6, or this could be the 6. So we could either have this triangle, or we could have this triangle. We could have an obtuse triangle or an acute triangle. So what do you have to do? You have to solve for both of them. You have to find all the sides for the acute and all the angles for the acute, and for the obtuse triangle, you have to find all the sides and all the angles using the law of sines, because there's two possible solutions. Okay? For time's sake, I only have about 40 seconds left on this video, so I'm going to go ahead and stop right there. There's one more example that I think I will cover in class tomorrow, and that's where we would have another side angle, but there would be no solution. No solution. So for side angle, we could have one solution, two possible solutions, or no solution, and we'll look at those tomorrow. See you tomorrow. You already have the assignment. It was on the board yesterday in class.